Okay, so thank you so much for joining. This is Exploratory Online Seminar number 31. This time, this session, I'd like to introduce the exploratory data analysis. This is going to be the three episodes series. This is the first one, and understanding the variance. Okay, so before getting started, let me introduce myself. My name is Kan Nishida, CEO, co-founder at Exploratory. I started the Exploratory back in 2016 spring with other partners in San Francisco, Silicon Valley. And then prior to starting Exploratory, I used to be working at Oracle, which is known for a database and application software company. And I was a development director building various data science products and delivering to the world. So I probably I spent about 20 years or so there. So all my career, basically, I'm always working with the data. And then the mission, to my personal mission, is always how to make it possible for more people to be able to access the data and use the data for themselves. And then I start seeing more innovation around open source instead of inside the private company. So I thought this is a time to actually go outside and then democratize what was called data science. So our company's mission has been always the same. This is democratized data science, and then to do we have this concept called the third wave. I think we are basically making that third wave right now. But the first wave, second wave, third wave, those are data democratization phase of the data science, as you will. So the first wave was basically the packaging the software. Making the software for the of the data science. So if you pay and then install, and then you can actually access the data science. But it was hard and it was super expensive. And then the 2000 comes with the big data, and because internet and mobile brought more data. So old software couldn't be deal with those new problems. So the open source communities to step in and then providing new solutions, or basically much cheaper solutions. So we call it sort of a commoditization phase. But the problem was all those, most of those open source software or package, algorithm, whatever you call it, were only accessible via programming. So the second wave was bigger from the compared to the first wave, but it was all sort of limited to those only be able to program. So the third wave that we are making is to bring that whatever the innovation was brought in this second wave to more people without or regardless whether you can program or not. So that's what we have been doing. And when we say data science, we always start with a question or problem you want to solve with data. So therefore, you need to access the data first, and then usually the data you get is not the way that you want in terms of visualizing the data or analyzing the data. So you have to work with the data. We call it data wrangling, basically cleaning up the data, transforming the data to get the data ready. And then you want to use charts and visualize it so that your eyes can understand or find the patterns and the trend in the data. But your eyes, well, we are human beings, so we have a limitation in terms of what we can see, what we cannot. So that's where the analytics comes in, such as statistics or machine learning algorithms. And then you go through this process and in any direction, any combination, and then until you find some hints or tips or insights or answers or whatever you want, then finally you can make decisions. But in the most scenario, you're not the only one who's solely making the decisions. You usually work with other folks, customers, partners, boss, teammates, whatever. So you need to communicate whatever the insights you find from the data very well. So the Exploratory provides a modern and simple UI to do these 5 steps of the data science. Okay, so that's enough for introduction. So let's get started. Exploratory online seminar number 31. This time, I'd like to present Exploratory Data Analysis, the part 1. This is going to be the 3 episodes, part 1, 2, 3. The first one, I'd like to start with understanding the variance. Okay, so I'm not sure people who are listening to this, watching this, how many people know this amazing player called Wayne Gretzky? And to be honest, I'm not really big or fan or familiar with ice hockey, but I heard about this person, this amazing person, and he made a couple very useful comments, and one of them, the comments being used a lot, probably you might have heard of it, is I skate to where the puck is going to be, not where it has been. And then it's sort of like kind of obvious, but we tend to forget when we doing a business or whatever, like we tend to react to what happened, and then we kind of get emotionally making decisions. But instead, what we should do is like, hey, where the puck is going, or where the business is going, where the whole thing is going in the next month, or within the next few months, or maybe like next year, then we should start planning. That's called strategy. So exploratory data analysis, it turned out it's a really great, useful tool to help you actually do that. So exploratory data analysis, the name exploratory, which happened to be the name of our company and our product, but sounds kind of playful. It's kind of a nice name. So like, well, like exploratory data analysis sounds kind of fun, sounds easy, but it's actually more than that. It is fun, it is kind of cool, but it is more about the method of rigorous and iterative analysis of the data. So before going there, so like what is data analysis? We talk about data analysis all the time, right? So what is data analysis? Well, usually in a business scenario, like you have a goal, right? So let's say like we want to grow our business, and then how we do that. So what is the problem in order to grow the business? Well, one of the problems, obvious, is we want to increase the number of the customers, and how we're going to like increase the number of customers. But this is a problem, sort of a business problem. So in order to address this problem, we have to quantify this problem. So let's say like the first step is to, hey, you know what, like we want to say number of the customers. This is very obvious. I mean, not talking about anything special here. So like we want to monitor this number of customers. Let's say 10 customers or 15 customers, or whatever that is. Then first, we can start talking about how we can increase customers from like 10 to 20 or 10 to 50 or whatever. So so here, then we have to think about like, okay, so number one is prediction. So the predict how many customers we will have. For example, end of this quarter, end of this year, like how many customers we will have. And this is important because once you know, or once you kind of focus the predict, then you can prepare. For example, hey, you know what, if we need to hire this number of people, we need to have like this number of systems or resources, and so, or we need to maybe like provide special training to prepare for this number of customers. And another aspect is a control. The control is about like what we can do to make that happen. Let's say instead of like we are going to have 100 customers by end of this year. Instead, how can we get to the 100 customers? Right now we have 10 customers. What can we do to increase number of the customers? And that's really the ultimate sort of question that we want to answer when you do the data analysis. But it's not that easy. Then if we can know, for example, like how to control sort of like the future, then you can make decisions about maybe, like we should provide a discount so that we can attract more customers, or we need to hire more salespeople, or, like we should do more like a Facebook advertise, and so on, right? So what we're saying here is, let's say sort of like a goal is predict how many customers going to be, or what we can control, meaning like what we can do to get the 100 customers. Either way, we start with hypothesis, right? So that's regardless of the name, like that's what we do every day at the business environment, or not just business, but in any sort of like organizational environment. And then, hey, you know what? Maybe number of the customers, let's say like we're selling like, I don't know, food and a hot dog or something like that, then maybe weather might be the huge factor. If it gets warmer, we will have more customers or something like that. So then, if based on the weather, we can predict how many customers are going to be. And on the other hand, the control is, let's say, like if we offer 10% discount, then we would have this number of customers. Now, either way, these are still hypotheses. We talk about this like when we get together in the same room, discuss. These are the hypotheses, right? Because we don't know what actually going to happen. This is the idea. And when you have hypotheses in the science world, you want to experiment and then collect the data, right? So let's say like, hey, you know what, like let's discount like 10%, and then let's wait for like 3 weeks, and then let's see like how things going to be, and then collect the data, like it's really increase the number of the customers or actually decreasing, whatever the is, collect that as a data, and then we're gonna test it or analyze it. Right, because just because increase the number of customers, like let's say like 5 customers, but what that mean? Because if we didn't do it, then maybe like we get 5 customers increase anyway, or maybe not. Maybe just purely the discount is really working. So that type of things like we need to do. Like this is called like A/B test or hypothesis test, whatever. And these are the type of the data analysis they call confirmatory analysis. And this is like an old school science thing. This is nothing new. Like that has been done for like over the, I don't know, maybe like last 300 years since the beginning of modern science. That's how it's been. But then the question here is how we can build this hypothesis. Like you said, like a discount of the 10%, or maybe like weather might matter. But where did you get that idea? Or how about like more idea? Do you have like what's the best way to get coming up with a hypothesis? And then in a business environment, this is probably 90% I mean, depends on which culture, which region you are. But most of people come up with this hypothesis based on intuition. And intuition is also sort of like kind of based on the experience. So like the longer you've been working in one industry or one function, you better tend to have a better hypothesis because you have a lot of experience, you have seen a lot of patterns, and then you remember those patterns in your brain, right? But how about data? Instead of like using data only to experiment and test the hypothesis, what if like we have the data, right? I mean, like this, especially today, you have data everywhere. Can we use that data to build the hypothesis? And that's what this person called John Tukey sort of proposed in the 60s and 70s. And he published this book called Exploratory Data Analysis in 70. I forgot, like 73 or 4, something like that. I highly recommend, though it's not that easy to read. I'm sure like you guys are okay, but I had a little hard time understanding his language. But this exploratory data analysis, or EDA, is really about using the data to build a better hypothesis by exploring the data. So EDA is an exploratory and iterative process of asking many questions and find answers from data in order to build better hypotheses for explanation, prediction, and control. And I think this is a really important part. And then because of this, to me, and also to many other folks as well, this data analysis is really the exploratory data analysis. So like I said, like data analysis has 2 types of analysis. One is confirmatory, the other one is exploratory. Most of the time, what we engage when we say the data analysis is really this exploratory data analysis. Okay, so today I like to demonstrate this exploratory data analysis, and by using employee data, which has 1,470 employees, and then each row is each employee, and then it has information about employees, such as age, such as what types of functions they perform at this organization, or education level, how much they're making, that kind of information. Okay, And then I like to set one goal here, which is we want to understand how the salary in this data, we call it monthly income, is decided. Why some people high salary, why some people like lower salary, like how that's being decided. That's what we want to understand. And to do, we want to ask many questions and find answers from the data. I'm hoping we can get some hint from the data. Okay, and then one very kind of famous comment from John Tukey is far better an approximate answer to the right question, which is often vague, than an exact answer to the wrong question, which can always be made precise. So this is, I think this is really, he got to the point. I mean, this is the essence of data analysis, or even data science, or even sort of like life, like we always explore the meaning of life and stuff. But I think this is it's important to what are the questions. So of course, question is, hey, like how the salary is decided, but also how we can approach this data. Do we just look at the monthly income, that's it, or how, what is the best way to approach the data to get the answer? And the two principal questions for exploratory data analysis. And I think this is really sort of like, even to me, was a kind of a key moment. Sort of like, oh, these are the two core things. And once you get this, and then when you look at the data, it helps you to sort of like, what to look, how to look, sort of things. So number one is how the variation in variables. So variable is a column in that this table data, like salary or age or etc. And then like how each variable or each column, the data in there varied. And the second thing is how are the variables associated or correlated to one another. So employee data we have, and then this is a histogram. I'm going to explain what the histogram is right after this. But when you visualize it, and the average salary in this data is $6,503. However, some people make way more than $6,000, and some people make way less than $6,000. And it depends, which employee. Like you see a lot of different salary. So it's sort of like average doesn't really tell you the whole picture. People have different salaries. And these are called like variation. And by the way, this data has a relatively big variation of the salary, right? And then, but the variance is an opportunity for data analysis. Because if you don't have a variance in the data, let's say like everybody making $10,000 in this company, and then like you ask a question, hey, how do you guys decide the salary? And then the answer is right there. I mean, there's nothing. Nobody decided. It's always $10,000. So that's the end of data analysis, and then you're done, right? But so sort of like variance is sort of like, everything in this world has variance, and then variance is sort of a good starting point for building hypotheses of association or even causal relationship. And if there's a variance, we can ask what makes the variance, and that's a starting investigation point, right? So, and then I start talking about this association or correlation stuff. So once you want to understand the variance. Is there variance, or how big is the variance? How the variance is. Then the next question is what makes the variance? And this is where the association and the correlation come in. So they are a relationship where changes in one variable happen together with changes in another variable with a certain rule. Association, correlation, sometimes I kind of use it in a mixed way. I'm not really the academia person, so like I don't want to like make it define like in a detail, but just to give you kind of overall idea, is association, correlation, basically the same thing. It's both of them are talking about the relationship between two variables, but association tend to be used for category. correlation tend to be used for sort of numerical variable or something that's linear. So, for example, association is, let's say, like, hey, there's a country like US and the UK, Japan, and then an employee in each country have different range of the monthly income. So this is a relationship between the country and the monthly income. So that's called association. And then correlation is, for example, age, monthly income. See this, like age now instead of country was categorical or sort of text or character. Here, age is numerical. And then monthly income is also numerical. And then the relationship between those two are kind of between relationship between two numerical variables. And those tend to be, not tend to be, those are called correlation. But that, name definition stuff is not as important as sort of like the whole point of here is that is there any relationship between two variables? And if there is, then how the relationship is. I think that's really the key point. And then if it's numerical, I'm going to talk about this correlation stuff in next episode, which is next week. But there is a way to calculate the strength of the correlation between -1 to 1. And then if there is no correlation, we call 0, strong positive correlation, 1, and so on. So why association and correlation are important? I mean, sort of kind of a dumb question because I already answered that, because what makes a variance? But let me just revisit again. So the data has a variance, right? Sort of between like $1,000 or $20,000, depends on the employee. Like, there are a lot of differences. So there's a problem because, hey, like we don't know like what's the monthly income of this company. So when you join in this company, you have no idea because like you might be getting paid $1,000, you might be getting paid $20,000. So this variation called uncertainty in a kind of in this world of statistics. So, but if we can find a correlation, let's say between monthly income and working years, how many years you work at this company, then there seems to be a strong correlation, positive correlation. The longer you work, higher you get paid. Then what just happened is, based on the working years, you can sort of like predict or you can estimate how much you might get paid. And what just happened is it reduced the uncertainty. Before, it was sort of like this one, the left-hand side, the number is kind of wrong. It says 105,000, but think of it like 1,000 to 20,000 on the left-hand side as well. But now, by using the working years information, then the variance get much smaller. In this case, it's saying $15,000, but there is still like even like your working years, 20 years, still variations. But nonetheless, the uncertainty got much reduced. And also the other association. Remember, the association is not between a numerical and numerical. The association is about between categorical and a numerical, or categorical and categorical. So in this case, country. So if you are coming from US, then you can expect, how much you are going to get paid, right? Because if you're coming from Japan, much lower. If you're coming from US, much higher, and so on. Again, we just reduce uncertainty. Okay, so if we can find strong correlations, then it makes it easier to explain how your salary changes, monthly income changes, and predict what monthly income will be. But there's one warning. This is probably like you might have heard many times, and it's sort of like you kind of tired of hearing this, but I just need to emphasize anyway. Correlation is not equal to causation. Causation is a special type of correlation. So this difference tend to forget, and even like the people like me who stayed in this ended up like making a mistake on mixing up this causation and correlation because we are human beings. But nonetheless, if we can confirm a given correlation or association is causation, there's a way to sort of like test out if that's a causation or not, then we can control the outcome. And that's the sort of like amazing thing. If we can control the outcome of the future, that's ultimate goal. Any business can thrive, but that's not that easy. So that's why we are where we are. Okay, so having said that, I just wanted to set that sort of like a basic for the exploratory data analysis, the purpose of the exploratory data analysis, and the methods of the exploratory data analysis. It's really simple. It's just really these two, trickle down to these two principal questions. And in this episode, in the remaining time, I like to focus on how the variation in the variable, how we can investigate, how we can understand the variation of each variable. Okay. And again, John Tukey is the godfather of exploratory data analysis. He made another very important comment. And since the aim of exploratory data analysis is to learn what seems to be, it should be no surprise that pictures play a vital role in doing it well. There is nothing better for making you think of questions you had forgotten to ask. Bracket, even mentally. So this is why I said probably like if you are English speaking, native English speaking, you have no problem understanding this. But I'm a Japanese, so like English is second language. So like this, his way of saying is, once you understand it, it's amazing. It's really kind of cool, but it takes time for me. So I don't know about you, but anyway. So in all, sort of chart or visualization actually is a great tool for exploratory data analysis. I think that's my understanding. So visualizing variance with charts. There are a couple of charts we can use: histogram, density plot, bar chart. And I like to cover these three, starting with the bar chart actually. And there's a job role in this data. So I like to just kind of jump into the exploratory. So let's import the data. I'm going to use the employee data. Where is that? Here we go. And then nothing new, just import that data here. And then the first thing you see after you import the data is this summary view, right? Like if you're exploratory users, you're probably familiar with. And then you have like an age, attrition, business travel, and so on. If you happen to be using a tool like Excel, this is the format you see, right? So like you have all the columns, 27 columns, and 1,470 rows. Each row represents each employee. Then the summary view is basically already kind of sort of like automatically visualize the variance. So having said that, sort of like once you open the summary view, the first phase of the exploratory data analysis sort of done in terms of preparation wise. Now it's up to you how you want to understand, how you want to interpret. So let's look at the age. So age is between 18 to 60 years old, right? So it's sort of like expected, and kind of this is a good old company that you can retire at 60 years old. And then like a medium is 36 years, and then mean or average is 36.92 years old. Okay, and then when you look at here, there are a lot of people around this age. So anyway, I want to actually go to the chart, and I want to introduce this like a bar chart and histogram density plot first. Then I'm going to go back to the summary view and then start kind of like talking about that same thing again. Okay, so let's start with the bar chart. What I wanted to do is first like job role. And if I assign job role to the x-axis and the y-axis default is the number of rows, meaning number of employees. And I can see that sales executive is the highest, 326 employees are sales executive. The next one is the research scientist and so on. Okay. Now, so this is sort of like also, we kind of like, this is a categorical, right? Like a job role is like, there are 9 different types. But also we are looking at the variation. So like, hey, certain job role has more employees, certain job role has less employee, and so on. By the way, you can actually sort by using sort by y-axis, and then now like it's sorted from the highest counts to the lowest counts. And we can see sort of like how the data is varied, and we can see like human resource has the fewest, least employee, and so on. So this is now like we're looking at a job role which happens with categorical. But what if like we change that to, let's say, like something like education. And education, this is like education, I think it's an education level. So like 1, 2, 3, 4, 5, probably high is the highest and then 1 is the lowest. And this is 1, 2, 3, 4, 5. And then this is actually numerical data type. So 1, 2, 3, 4, 5, that's that order. And it's basically what we are seeing here is sort of like in the same way we are looking at the job role. So like we can see like education number 3, it has the highest number of the employee, like most employee, 572 and so on. So this is sort of like very similar to categorical. But now like if I change to age, things start getting a little different. So first, now the x-axis says CAT. This is a category as a category. And when you assign numerical variable to x-axis with many unique numbers, then it automatically sort of like divide into each bucket. So like from 18 years old to 26 and 26 to 34 years old and so on. But this time, just to make it simple, like I'm going to switch to as number so that each year of the age has its own bar. And then let's say, for example, here at 35 years old has a 78 employee, and that's the highest or like as the most among others. And then, so age is kind of fine. I mean, there are too many bars, and then the before it was categorized, so like it was kind of like 5 bars. Now like we have about like 40 bars or so. And then now, but here x-axis, if I change to this like monthly income, and again, it does a categorical, categorized. So now like monthly income, this is a salary that I think that our goal in this analysis, by the way. And then now it's $1,000 for 1,800 or something. But instead, again, we want to do the same thing we did for the age. Instead of the category, like we want to present as a number. So I can change that to as a number, and then the chart becomes something like this. And it's almost like nothing's here. But when you pay attention and stares at this screen, there are some like a blue thing. And then y-axis is 1 or 2. Maybe some here around, there is something around 3 or 4 maybe. And what's happening here is when you look at the table and then data, the monthly income. And when you see, for example, the first person, $5,993, and then there are not many other employees happen to have exact the same amount, which is 5,993. So everybody has a different numbers, and then this chart is basically for each data point, and it gives a bar, but it happened to be like only 1 employee or 2 or 3 employee or something like that. Then here's a problem because we don't see any pattern. Like it seems like by looking at the color, like here, this area seems like there are more people because it looks like a darker color. It looks like there are a lot of bars compared to right side. So that's about it. But there's no pattern here what we can't see, and that's what happened with the numerical variable. So when you look at the numerical variable, this bar chart with just by visualizing the original number doesn't really make sense. So that's why it's actually better to categorize into a set number of the buckets. For example, this is 5 buckets. You can change it by using equal with like a default is 5. You can change to 10 and 20 and so on. But to do this sort of bucketing, the best chart is actually the histogram. And basically the same thing. I mean, at the end of the day, it's a personal preference. But the histogram actually can make this kind of visualization much easier and simple. So I'm going to switch to the histogram. And then the default number of bars is like a 10. I think 1, 2, 3, 4, 5, 6, 7. I think it's like a 1, wait, 5. Yes, 10 bars. And then instead of like a bar chart, each bar had a space from each other, but now histogram there's no space because the number is sort of like continuous. So there's no, like a space in a number anyway. So for example, here, 8,605 to 10,504. The next one should start with the same number, right? Or it maybe like, maybe 4.01 or 02 or whatever. But nonetheless, it should be connected. I mean, it should be separated. So that's the difference between histogram and bar chart in terms of how it looks, how they look. But just to, so histogram, probably everybody is okay with this, but just to categorical is there's no continuous relationship. As opposed to that, numerical, the continuous and the ordinal relationship among values. So what's continuous is like a 10, 20, and when you have 10, 20, you expect something between like 10, 11, 12, 13. And even when you have 10, 11, like you can still expect a 10.1, 10.2, and so on. So any place the values are always continue. You might not have the exact employee there, but the value itself should be there. So that's numerical. And then when you have that, for example, like in this case, what we saw in the histogram, when you line up all the employee from the lowest to the highest in terms of the monthly income, and then you create the bucket, let's say, or like any sort of like a criteria. Well, in this case, I created 5 groups and divided the numbers from 0 to 10,000 to 5 different groups. Then we want to actually display by using bar to visualize how many employees in each bucket, right? So that's really the histogram. And then the cool thing about here is just number of the bars. That's what you want to kind of like adjust. So right now the default is 10. How about changing that to 50? I type 50 and then click type return key. And then now that you kind of can start seeing the pattern. For example, if I type 100, okay, and then my pattern, what I mean is, for example, here there's a sort of like Empire State Building-ish kind of mountain here, and then there's another mountain around here, and then like there's another like around 10K, another mountain, and then around 14K there's another mountain. So it looks like what, different sort of like a chunk of the data. It might have nothing to do with, like just random chunks, or might be something meaningful chunks. For example, this group is different from other mountain because maybe, female, male difference, or education level difference, or job, type difference, whatever that is. And that's, again, this is a kind of a sort of exciting moment, at least for me, because my question now is how these differences are made, right? So there might be something to do with it. So you can use the color, for example, and then let's say like if I assign a gender, it's like a male and a female. And then, if male and female have a different patterns, a different sort of like shape of this data distribution. And in this case, it might be, but it's almost like I don't see anything significant in popping up in my eyes, right? So sort of like similar, kind of same. So how about job role? So like I changed that to the color to the job role. Then it's kind of hard to see, but something popping into my eyes is this red group. Like a red, what is red? It's a manager. So manager people seems to be like a right-hand side. And it seems like these mountain, like I said, like, here's one group, another group. This seems to be manager people. And then the Empire State Building looking shape I said was this like a research scientist. And it seems like behind this pink, there is something else as well. Like I'm gonna just hide the pink. And there's this like a green color, which is a laboratory technician. So these people are making much less salary than the manager or other folks, right? So now seems like, I mean, it's kind of obvious, but seems like depends on what job role you have, then you have the different range of salary. And that's the kind of information that's very important. And that is the association we are talking about, even though today that's not the focus. The focus still is the variation. But I just wanted to show you, once you have the variation, once you start seeing the patterns, and then you kind of like quickly move to the association correlation side of things. Okay. But the problem here, though, like I have to kind of hide each, pink, or like how about the behind the red, or maybe like there's something going on here, this between the 6K and the 10K, because there's so many colors. I mean, not so many, but 9 colors, and even 9 colors making already kind of hard to really understand this thing with eyes. And that's where we want to use something called density plot. So I'm going to switch to density plot. And the density plot is sort of like make the histogram shape to be more like smoother. And then another thing is each curve, for example, this is manager, and a red kind of like a curve. And under the curve, the area, the size of the area is 1. And then, for example, this sales representative is a kind of super high, but it's very narrow mountain. But this one also, under the curve, the area size is 1. So each curve has its equal amount of sort of like size. Then we can understand like what's the ratio, what's the percentage of data of the manager, for example, where. So for example, most of the manager people, between 15K to 20K or so, as opposed to most of the sales rep people are maybe in this range, like 2,000 to, maybe like less than 3,000 area. And then more condensed, more, employee getting the same amount of salary, then the range tend to be narrower. That means the size is always 1, so therefore the mountain goes higher, right? And then, but for example, manager seems like there's certain people higher getting a lot of money, but some people, I mean, all people are getting a lot of money in this company, but it seems like their range, like $5,000 difference. So when you have the wide range, and then the mountain tend to go down because it has to keep the size of the mountain to be always 1. So the density plot is kind of confusing if you haven't seen if you haven't seen it before. Just to give you some idea, I'm not sure if it's going to be enough, but each data point, in this case employee, and I just line them up based on how their employee monthly income value. Then we consider this as each employee. This person happened to be, let's say, like 5,000, but probably this type of people, like happen to be the same age, happen to be the same job role, happen to be this, and all the same condition, but probably not always 5,000. Maybe like can be 4,800, 5,200. There should be variation there. So therefore, one of the distribution curve that we use often in the statistics world is called normal distribution. Normal distribution is like the center is the average, and then kind of symmetric. So like a left-hand side and right-hand side is the kind of same shape and same way with kind of curve. That's normal distribution. So we draw normal distribution for each data point. And then we add up all the values of the normal distribution. So kind of put that normal distribution on top of each other, kind of. Then you get the whole sort of like one big curve, and that's really the normal density plot. Anyway, so by changing the histogram to density plot, then it makes it easier to see the different patterns among, in this case, the job roles. And okay, so density plot is about the ratio, like what's the ratio, or like what's the percentage of people getting paid. I mean, what range has how many employee, not how many, like what's the percentage of the employee distributed where. That's the really density plot. The histogram, on the other hand, it's always showing the count itself, the exact count, how many employees. So the ratio and the counts, that's really the difference. But density plot tend to give you better sort of like understanding if you're looking for the pattern. And histogram, it helps you understand the patterns, but also it's more for like exact numbers. So that's the difference. That difference is not you know, there's no rule, so whatever like easy tool like you want to use. But having said that, now understanding variance with exploratory is not, you don't have to create a chart every single variable. You just, like I said, you just go to the summary view, and then you already have the histogram being created. So for example, the age, we talked about that, and there's another column called attribution. Sorry, not this is attribution, this is attrition. There's a typo there. But just looking at here is like no, meaning hasn't left the company. Yes means this person has left the company. So 237 people already left the company, and that is 16%. If you move the mouse over on the ES bar, then you can see like 16% of that, or about 16% of the employee still, already left the company, and so on. And the job role, in this case, when you look at the unique values, it says 9. So that means there are 9 job roles in this data. But the bar can show only the first, sort of like the most frequent 6 job roles. And then, so if you want to see more, all of the job roles, you want to click on the chart icon. When you move the mouse over, then you can click on it, and then you get that chart as well. Okay, so that's the really summary view. Is nothing new. Probably you have seen that before, but it's really, that's the sort of like this is why there's always summary view in exploratory, because that's the key element of performing the EDA or exploratory data analysis. The second thing I would like to go is like a highlight mode. And by using this highlight mode, you can do even more detail. So let's say, for example, in a job role, there is a sales rep. There's sales executive too, but there's sales rep. It's not showing here because it's less frequent. But there's a sales rep. And what is the distribution of the age for this particular group? And that is how we can use the highlight mode. So let's go check here, go to the summary view. And then here's the job role that I was talking about. And then it's not here, but when you go to the chart, you can see sales rep is somewhere. Let's just create a chart. Okay, here sales rep is here. So there are about 83 employees, and I like to know like what are the age range. I like to even know like what's the monthly income range, or they have quit, how many of them quit company or not quit company, that kind of stuff. So go back to the summary view, and then that's where like you want to click on highlight view now in the highlight mode. And then what we can do is, oops, something is, oh here, okay, here. And then like I like to select job role, and job role is equal to sales rep. Where's the sales rep? Oh here, the sales representative at the bottom, and then click on run button. Then sales rep is highlighted. So whatever like this light blue thing we're seeing, those represent the sales rep people or employee. So for example, in a department, there's a sales rep is only in a sales department, of course. And then that means about 20% of sales rep, but in the sales department, there are other people, probably like those are sales executive and so on. And then when you look at the age, it seems like the sales rep people tend to be in a younger age rather than the older age. And then like attrition, there are 50 people who haven't left the company and 33 people have left the company, and so on. So you can see like we're talking about the variance, but also we're talking about the variance for the specific group. But here, like, we have to be careful, because when you look at here attrition, like, oh, it's about the same, like 50-33. Well, there's a difference there, of course, but you can't really see the difference. And that's, one problem here is like the all employee, like 1,233 people who haven't left the company. So there are a lot of them there compared to 237 people who left the company. So already the whole data is different. So like then we are seeing this, sales rep, has only like 50 and 33. we don't know, like it's kind of hard to see the difference between 50 and 33. So what we want to do, especially this kind of categorical stuff, we want to use a ratio instead of like a raw number. So against the whole population, or like number in this case, all the employees who haven't left or who have left, and what is the percentage of the sales rep? And then we can see sales rep tend to be, leaving the company easier or harder, or so on. So I'm going to click on this ratio button, right-hand side top. Did I click that? Oops. There seems to be some kind of weird bug that this one is not highlighted. If I click on percent ratio, this one should be highlighted. But nonetheless, the bar chart is now become 100%. Then now what we are seeing, the attrition is like yes and no. It's like basically yes, we have 13% of, or almost like a 14% of all the employees who have left the company is sales rep, as opposed to 4% of all the employees who haven't left the company is sales rep. So seems like among those who left the company, the sales rep occupies a higher ratio. So looks like sales rep folks tend to leave company easy. Tend to leave the company or something like that. So that's something we can see. Even like business travel, the sales rep folks, I mean, like among of those who does the business travel often, a higher ratio is sales rep. So it seems like a sales rep people tend to travel often, or business travel often. Even the age as well, seems like 18 and 22, seems like younger age tend to be the sales rep. Maybe this company, you start a career as a sales rep and then move on to something else, I don't know. But we can see the different patterns here based on the particular job role. Of course, we can change the job role or some other stuff. For example, what if like you're interested in like a higher income people who are making a lot higher, so higher salary, like what is their distribution of the age, what is the distribution of education level, and so on, then we can change it. For example, instead of job role, I'm going to use it like monthly income. And instead of equal, let's say greater than, maybe, I don't know, like 5,000. I think like average was around 5,000. So I'm going to just start with that. Okay. And monthly income of 5,000. Maybe like I should just make it even like a 10,000 or something. So, so in this company who are making greater than $10,000, where are they? And the job level seems like greater than 3. Education, there's not much difference. It seems like higher educated folks tend to be making more money probably. And then gender, female has 20%, so seems like it's more female employee in this higher income range. And attrition, this is kind of, I can see like a big difference. The people who haven't left tend to make higher income. It kind of makes sense, but nonetheless. So by creating this condition, this can be equal or greater than or whatever the condition you create, then basically you're not only looking at the variance of each variable, you're looking at the variance of a particular category or particular group for all the variables. Okay, so that's the kind of how highlight feature is actually useful in terms of like when you're doing an EDA, explorative data analysis. Okay, so time is kind of like running up, so I'm going to kind of conclude this thing. So with the summary view and its highlight mode, we can quickly understand how the variance of each variable is. And then let's go back to the 2 principal questions for EDA. Like the first one we just look at is how the variation in variables. That's the first step, and it's a very important part. And then when you see the variation, that's actually the opportunity. That's the kind of sort of like a beginning of the data analysis. And then the next step is how the variables associated or correlated to one another. And in the next section, we're going to explore how to investigate and understand the relationship, which is particularly correlation and association between the variables. So that's going to be a next week at the same time. And then if you want to find more detailed information, you go to our website, and at the header, there's a Learn, and then online seminar, and click on it. And then you have the more other seminar-related information as well. Okay, so that's it. If you want to, if you have questions, please ask me now, or after this seminar, you can shoot me the email, or we have Twitter account, and so on. Okay, so I think that's all. And do you guys have any question? If you you can use the chat window, or you can actually speak up. You're on mute, so you want to unmute and ask a question.